opportunity here to sign into Poll Everywhere. I have the link here, and it'll pop up when we get to, there'll be 2 questions that will pop up to get a little bit of an engagement from you all. So the first case here, I'm just going to jump right into these 2 events that kind of motivated this talk. The first one here happened in the Paducah area. I'm not going to give any of the dates yet, intentionally. So in this case, we're looking at a day 6 to 7 forecast. In this case, actually, I happened to do one of those science sharing presentations on, because you've got this nice deep southern stream trough tracking across the desert southwest into northern Mexico, pushes this decent sized ridge into the southeastern US. You see in return, you get some moisture response come up out of the Gulf. Precipitable waters get pretty decent, 1 inch or so, for especially this time of year that this image is taken. You've got 2 atmospheric rivers depicted, one coming out of the eastern Pacific and one coming out of the from the Caribbean up through the Gulf, all converging into the Ohio Valley area, and then a nice right entrance region of a pretty anomalous upper level jet. And a lot of these images here coming from that ensemble situational awareness table. The antecedent conditions in this event for the Ohio Valley area are already fairly moist. 40–50%. So, the conditions could be ripe for flooding. So you're kind of thinking about that messaging aspect of, hey, I've got a pretty anomalous situation, and now I've already got moist soil, so maybe we might have some flooding with this case. And so, if you're curious what the precipitation forecasts were, this is from the European deterministic at the time. Pretty substantial QPF amounts on the order of 4 to 6 inches, even a pocket there approaching 8. And again, it's you got a collision of atmospheric rivers, pretty good upper level force to help result in this. And if we look at the actual all the individual members kind of coming up out of the European ensemble, this graph doesn't contain the whole event. Only goes maybe about a day into it. You see there are several members here that are approaching. Those are the approaching or exceeding 1 inch. Those are the values here kind of colored in blue, and even those in yellow. And there's a red one there that's approaching 2 inches. And again, we're only going part way through this event. So there's quite a bit in this ensemble that is suggesting, hey, this could be a decent event. So if you look at the NBM, again, this is version 3.2 at the time. You kind of have the same theme here as the European deterministic when looking at the probabilities of greater than 1 inch, kind of center point around the Paducah area with some fairly high probs. Note again, this is a 24-hour forecast for days 6, 7. Looking at the 90th percentile, kind of thinking, well, what could be a potential maximum? Noting this again, it's just 90th, not all the way up, but pretty significant values there in that 2 to 3 inch range. And again, you're getting the same theme that we saw in the European deterministic with this broad area around the Ohio Valley. So with some of the information I've presented thus far, I'm going to let you enter in what you might think of a potential QPF forecast. Think of yourself like in the position of WPC, where they're having to provide day 4 through 7 QPF forecasts, and I know some of us do populate day 4 through 7 QPF in your forecast. So I'll give this about another minute or so. I'll lock them in. All right. Well, I'm gonna lock the poll in. And so, yeah, I mean, I think this seems pretty reasonable. We got a few in that 1 to 2 and a few greater than 4, but a lot kind of been maybe a little bit more conservative compared relative to what we saw of the European deterministic, given the time in the forecast, time range of the forecast. And so, yeah, let's see how this plays out. So the synoptic evolution here, well, the southern stream trough ends up digging more south with time. In fact, it almost closes off into a low there down in northern Mexico. And instead, you end up with more influence out of the northern stream trough coming across the northern US, and you get this flatter ridge. And so the result is that the whole axis there of QPF and all the synoptics that have been associated with the atmospheric river and all that never materialized across the Ohio Valley whatsoever. And in essence, no precipitation fell in Paducah. Quite disheartening, going from what looked to be, a pretty solid case out in that extended time range, and here you go, nothing happens. So let's take a look at another case. This one happened up in southern Wisconsin, Milwaukee's area. So again, the previous case I gave you, which was something 6 to 7 days out, yeah, there could be a potential that case wouldn't pan out, but it seems pretty extreme that you're going to go from something that looked really great for a lot of QPF to absolutely nothing. So again, this one 3 days out, you look at these NAIF means, suggests a pretty decent trough here, situated over the central U.S. I would say probably like a neutral tilt. You get this fairly decent low pressure system to develop over the northern Ohio Valley into the southern Great Lakes. Looking at the negative U wind anomalies at A50, one of those kind of proxies that I've seen in a lot of the heavier precip snowfall events, you get this decent, northeasterly flow. That's a good sign anyway that you could end up with, this snow band on the northwest side of the system in that cold conveyor belt region. So how does this system play out in terms of precipitation forecasts? Here's the NBM snowfall probabilities, and again, this is 3 days out, and you're looking at a 48-hour time span. Probabilities of 8 inches in 48 hours, pretty substantial here, near 50%. In fact, if you go into the percent, look at the some of the numbers, and even you can see this out of the percentile data, you got even a 5% chance of greater than 24 inches. Pretty substantial. So for the PWPF, the starting forecast that we have here, again, you get to that day 3 time range, you got to start putting in some snowfall amounts. So what was put in by the forecast office was about 8 inches here, which sort of splits the difference here between the percentiles, pretty close to the 50th. From the whole overall PWPF, your 10th percentile there 4 inches, your 90th 12. So I know I don't have a lot of data presented thus far, but I'm curious what your snowfall forecast would be for Milwaukee. Again, this is just that entering one for 3 days out. I like those couple at none. Ooh. I mean, come on, this looks pretty good, doesn't it? All right. Well, I'll try and see my lock feature on this, but as you can see, we've got quite a few in that 1 to 5 and 5 to 10. I gave some larger ranges here just because I didn't present a whole lot of data, but I thought this would be a good starting point. And you get a couple on those higher amounts, and it's good to kind of see this distribution. But most of that 1 to 5, 5 to 10 area. All right. So let's go into what happened with this case. So we're going to follow the 90th percentiles. Going 2.5 days out, sort of close to again where that PWPF trend graph was. We're at maybe upwards of a foot potential there across southern Wisconsin. Again, the 90th percentile, you wouldn't expect to see this everywhere, but at least some points seeing upwards of a foot. Well, here we go. 2 days out, still have potential for a foot, but it's starting to slide south. And now 12 hours later, it has shifted even farther south and it is weakened. So let's see this from an NBM point evolution for that 48-hour snowfall. Start with the top is where we were pretty close to what we discussed at the beginning of the presentation, but look as you go in time. You get less and less as you go through 2 days out, and then by the time you get to 1 day out from Milwaukee, you're pretty much down to very little snowfall. And so how did this look in the PWPF realm? Courtesy of John Gagan there at Milwaukee, grabbed a PWPF trend graph for several forecasts during this event, and you can actually see the date of this event. Similar to what we saw at the NBM snowfall probability graphs, it's the same kind of concept here, that decrease in trend minus that one forecast there at the 12Z on the 23rd where it kind of spiked up in the WPC. Noteworthy here that the forecast from Milwaukee here, that's the black line, was near the 10th percentile, and even that, when you look at earlier in this case, was too high. Now, just for reference, for Milwaukee climatology, 6-inch snowfall events per year at any location is generally about 2 to 3 over the course of a winter. So to see, something substantial like this, for example, take that 12Z to 23rd with that, to have something that might reach up to 24 inches is pretty rare. I should note that the Milwaukee office started to catch on here pretty early in this case, and that's why they stuck down there again towards that 10th percentile and kind of kept the snowfall amounts down. And in the end here, and as you can see by the PWPF trend graphic, that no snow ended up happening. So another case where you went from what looked to be a good case for heavy precipitation, and it just didn't pan out. So, what are some kind of takeaways from these two events? The first, and there's gonna be several here that I'm gonna present. The first is to take caution here with ensemble means. They're somewhat easy to look at because arithmetically they're pretty easy to calculate. The problem is that the ensemble mean doesn't give any information about the distribution. So if you have let's just say, for example, you have a normal distribution, but it's really wide, you have long tails, that mean is not going to give you any kind of information with respect to that, nor represent that solution appropriately. Similarly, if you have a bimodal distribution, let's say storm tracks, a group you've got farther south, another track that's significantly farther north, that mean is just going to split the middle and not be probably the right meteorological forecast. Another point here is to watch out for the NBM PWPF to some degree, and that's because it's a small subset of the PQPF, and there are very few members in days 4 through 7. And let's talk a little bit about that. For those that were on the WPC briefing yesterday, they discussed about the membership in their PWPF, and on the right is the NBM PWPF. You can see that, and at the very bottom here, once you include some stuff with the QMD techniques, you get a total membership of about 25 in the short term and 15 after 84 hours, whereas the WPC is upwards around 60 for the entire short term through day 4, so significantly less. Now, I'm going to give you a caveat on the WPC, which they discussed during the briefing yesterday, is that for example, for like precipitation type for the European ensemble, that they're only utilizing standard level pressure data to come up with a P-type diagnostic. So if you're in like a transition zone, there's some caution to the WPC, and then again on the NBM side, there's caution because of the number of members. So PWPF, still a little tricky, still under development, but it's, you know, I think in both cases they can give you some information. I do encourage you to look at something like the PQPF distribution, and that will help you get a little more idea, because it's got a bigger spread of membership to be able to look at certain events, including winter events. Another lesson coming out of this is dispersion. Certainly, you know, we and I think, you know, the Weather Service as a whole is trying to move more towards ensembles. But something to keep in mind is that whether you're talking about the deterministic models or ensemble systems, there is under dispersion. On the right is an image of some image of clustering techniques applied to U.S. East Coast storms from November through March, from a pretty long time span there, about seven years. And in all of these situations, you know, they've got some clustering up top, and then they bias correct them on the bottom. They're all above 1, which implies that they are under dispersive. And so, you know, you got to keep in mind that it's possible that a verified event may lie outside the ensemble. So, taking this information together and when to assess confidence of an event, there's several things that you must know. First is the synoptic pattern have a lot of predictability? You know, things like phase-in, banded snowfall, those are going to be historically low predictability events. You know, take the banded snowfall, for example, is often only account, 30, 40 miles wide, that you see a band of very heavy snow. Trying to place that certainly at something like at day 3, for example, is going to be pretty tough. Certainly you could message it that somewhere in some zone could have a significant amount of snow, but we don't know exactly where that will pan out. And certainly phasing is another one of these that are all these things really going to come together to phase? And especially if you're out farther in the forecast, that could be harder to figure out. As I mentioned on the previous slide, under dispersion remains a problem. Therefore, if you're just using the PDF to determine confidence, that is incorrect. Again, you got to take into account, is this pattern predictable? You know, how does the forecast event look compared to climatology? You know, take for example that second case there in southern Wisconsin, where there was one of the percentiles suggesting 20 inches or even more. Seems pretty high for what they would have for climatology. And one of the ways you can do this is, look back at your past events for all sorts of different phenomena, whether it's cold, heat, severe weather, flooding, and understand what are the synoptic patterns that have historically led to those. Look at all those big QPF events, your big snows, and document them. And so you have that as a reference when you come into one of these. In fact, you can have a double bonus with that, because when it comes time for messaging, you actually have that material to look back at, and some users may actually know that event and be able to take appropriate action. And finally, forecast trends. In the past slides, I kind of showed how the PWPF trended out. Utilize that information to help you gain confidence in how the scenario could play out. And finally, to conclude here, what we really need is some sort of measure of predictability based on a given pattern. And there's been some work done with this. There's this reference to paper from just last year. I think that's in Weather and Forecasting about this predictability horizon diagram index. But I think, according, if I remember reviewing that article, there's still a lot more research to be done there. A lot of this is done with looking at in hindsight cases. There hasn't been much done in terms of actual a forecast. But even in that paper, it references a lot of this material discussed here that we really need something to help us figure out the measure of predictability, and that will help us in the IDSS realm as well. And with that, I will open it up for questions.